Welcome to the Walton Pi. Today we're going to go through some examples of how we might be able to use the fundamental theorem of calculus. Let's do a couple examples showing how we can use the first part of the fundamental theorem of calculus. So let's say that f of x is equal to the integral from 3 to x of t cubed sine of 3t e to the 2t plus 7 dt. If we want to figure out what is f prime of x, the fundamental theorem of calculus says that we can just take our function in here and replace the t's with this top and then multiply by the derivative of that if necessary. So that means that the derivative of f is just going to be x cubed sine of 3x e to the 2x plus 7, all of this multiplied by the derivative of x, which in this case is 1. So that's how we can figure out f prime of x. So if we had a second function, like g of x is equal to the integral from negative 3x plus 2 to x cubed minus 7 of cosine of 3t e to the 2t minus 5 dt, and we were trying to figure out what is g prime of x. This is going to then be our function evaluated at the top minus the function evaluated at the bottom, but we are going to be multiplying both of them by the derivatives that would come out through the chain rule. So that means that our first one is going to be cosine of 3x cubed minus 21, because that's 3 times x cubed minus 7. So we have e to the 2x cubed minus 14 minus 5 multiplied by the x cubed minus 7, the derivative of that. So the derivative of that is 3x squared. So that's our function evaluated at the top, and then we subtract from that the function evaluated at the bottom. That's going to be minus cosine of 3 times negative 3x plus 2. That is going to be so 3 times negative 3x plus 2, that is going to be 6 minus 9x. We have e to the 4 minus 6x minus 5 multiplied by the derivative of negative 3x plus 2. That's multiplied by a negative 3. So that's how we are able to figure out g prime of x. So g prime of x is going to be 3x squared cosine of 3x cubed minus 21 e to the 2x cubed minus 14 minus 15x squared plus 3 cosine 6 minus 9x e to the 4 minus 6x minus 15. That is our function for g prime of x. Let's talk about a couple problems for the second part of the fundamental theorem of calculus. So that tells us how we are able to integrate something like the integral from 3 to 4 of 5x to the 4th. So this says that if we can find an antiderivative of 5x to the 4th, we can evaluate it at 4. So this can be equal to f of 4 minus f of 3, where f is the antiderivative of 5x to the 4th, meaning that f prime of x is equal to 5x to the 4th. Well, one function whose derivative is 5x to the 4th, we could say that f of x is just x to the 5th, because the derivative of that is 5x to the 4th. So that means that the integral from 3 to 4 of 5x to the 4th is equal to 4 to the 5th minus 3 to the 5th. And so that is the answer to this integral. We would have to go through and compute whatever that is, but that is going to be what the answer would be. And this is going to be the same no matter what function we have. So if we had the integral from negative 1 to 1 of, let's say, 2x, well, here our antiderivative might just be x squared, because the derivative of x squared is 2x. So this is going to be equal to, we have f of 1 minus f of negative 1. So this is going to be 1 squared minus negative 1 squared, which is 1 minus 1, which is 0. And if we were to look at the graph of this function, that sort of makes sense, because what we're doing is we're saying, take this area that comes before, and then take this area that comes after, combine them together, and those just cancel each other out. Whoops, I have those on the wrong side, so let's draw that accurately. There we go. So this area here on this side cancels out with this area on the other side, and so the integral is in fact going to be 0. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already, so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.